What is the ratio of weight of an object on the surface of the moon to that on the surface of the earth? So basically the question is asking this. The object's weight on the moon, we have to divide with, can you guess what? Yes, weight of the object on the surface of the earth. So to put it as a diagram, again this is only for understanding diagram, so that there is clarity in what we are doing. We have earth. I can do a better job. Yeah, that's better. And we have the moon. We have kept the object on the surface of the earth, say somewhere over there, and on the surface of the moon, somewhere over there. So what is the weight that it's experiencing? So to find that, we need the information of distance of from the center of the earth to the center of the object. Same thing over here, center of the moon to this. All this information is required. It will be approximately equal to the radius of the earth. Here it will be approximately equal to the radius of the moon. Right? Makes sense? This information is required. Why is it required? Because as per what law? Can you guess? What law should we use? Newton's law? Universal law of gravity? What should we use? Yes, we should use universal law of gravity. What does it tell? Well, if we have two objects, the force between them, the gravitational pull between them, is given by product of their masses, and it's inversely proportional to the square of their distance. When we remove the proportionality symbol, we get a constant. That is your gravitational constant. Right? We saw this. Okay. Now we are going to make use of this. Find the weight of the object when the object is kept on the surface of the moon. Weight of the object when we keep it on the surface of the moon, and weight of the object when we keep it on the surface of the earth. That's all. We'll need to apply that. So let's begin with this. So weight is same as force, right? Force and weight. No, all weights are force. That is, weight is a form of a force. So we can just write this as weight of the object on the surface of the moon, which is equal to G, right? It will be the same thing. Mass of the object into mass of the moon divided by radius of the moon square. Okay guys, and by the way, sorry, I forgot to mention this. This is only to understand a particular relationship, and that relationship is what you have in your syllabus, not this calculation per se. This is only for understanding, and it's not too much. So even actually by chance, if they do ask you to derive this out, they'll give you these values. Till the last moment, you just have to do the working which I'm showing, and later on you substitute it and cancel things and write the final answer directly. You need not calculate per se. Don't get scared with these values. Okay guys, I'll show you the trick. I don't think they'll ask this, but still, let's prepare for them asking this. Okay guys, so it's very simple. It's not too hard. So we just have to write universal law of gravity. Write this case, weight of the object when we keep the object on the earth. So that would be weight of the object on the earth would be equal to, again, G, mass of the object, mass of the earth, and radius of the earth. Okay, I'll do this. Right guys, make sense? Now what should we do? They're asking for the ratio, is it not? All we have to do is divide 1 by 2. So the next step is dividing equation 1 with equation 2. So what do we end up with? Weight of the object on moon divided by weight of the object on earth. So that would be equal to, the numerator would be G times of mass of the object into mass of the moon divided by radius of the moon square. Okay, this entire thing is divided by open brackets. Let me use some other color. Open brackets g times of mo, mass of the earth divided by radius of the earth square. So this is equal to g m naught mm divided by rm square into 1 by g re square divided by m naught and me. And we have cancellation. All that is possible. Have a look. Check what I cancelled. Can we cancel those, or was I wrong? So gravitational constant is gravitational constant. M naught is mass of the object, right? And at last we have re square by rm square into mass of the moon divided by mass of the earth. All we have to do now is substitute. So I have the value in front of me so that I don't go back and forth. So radius of the earth is 6.36 into 10 to the power of 6. Since it's square, I need to write it twice. Into mass of the moon. Mass of the moon is 7.36 into 10 to the power of 22. This entire thing divided by radius of the moon is 1.74 into 10 to the power of 6 into 1.74 into 10 to the power of 6 into mass of the earth is approximately 6 into 10 to the power of 24. All we have to do is now look at the calculation. Check what and all can we cancel. Please pause and look it over. We can cancel 6, 6, 6, 6. Then everything else is matter of using the calculator. So 6.36 square into 7.36 divided by 1.74 divided by 1.74 divided by 6. Okay, I think I did something wrong. Mass of the moon is, that's correct. Mass of the earth comes in the denominator. Radius of the moon, that's correct. Okay. Oh yeah, it's inverse of this. So we have to take the inverse. I'll explain why. So this will be 16 into 10 to the power of minus 2. 16 into 10 to the power of minus 2. So basically this would be 16 by 100. Okay guys. So if people who didn't understand that, it's 16 into 1 by 10 square, right? I've taught all of this in basics. You guys have to have a look before coming down over here. Okay, if you're not able to understand how is this and why is this, you need to know that. Exponents and stuff. So 100 divided by 16 is 6.25. Actual answer is 1.1 by 6. I approximated this value maybe because of that. Not maybe, it's because of that only. 6 into 10 to the power of 24 is not that. Did I take some value wrong? Okay, it looks correct. So end of it, this is your answer, 1/6. Okay. So final answer is 1/6. So you need to write all of these values. Just write 1/6. And yes, you need not memorize this value. This is not to be memorized. Okay, agree? So this is what we are looking at. That is, what does that mean? End of it, what does this mean? Weight of the object, that therefore weight of the object on the surface of the moon is 1 by 6 times, or 1 by 6th, or 1 by 6 times that of weight of the object on the surface of the earth. That's all. Okay, for example, if we weigh, oh yeah, I'll show it over here. If we weigh, say, almost approximately 100 Newton, on the surface of the moon, it will be 16 Newton. So let me take some other value. I want this to be 600. So 600 is, how will I get 600 guys over there? 60 kg, approximately 62 or something. If I take 62, yeah, almost close to 600, and look at on the surface of the moon, it is 1/6, is it not? Right? You got it? How to go about understanding this? So on the surface of the earth, if we weigh around 600 Newton, on the surface of the moon, we will be weighing around 100 Newton. Right guys, understood? So it will be 1/6 your own weight on the surface of the earth in comparison to that. Again, all this calculation, I think I took some value wrong, I guess. You will get 1/6 only. I did calculate before. Yeah, it's 16 point odd, that too. Yeah, I took that wrong. It's not just 16. This is approximately. But yeah, final answer turns out to be 1/6. That's what your textbook tells. So we'll just go with that. Okay. So approximately. I took this value wrong. It's 16 point odd. You guys saw that, nah? So if you go, I mean, if you take that, it will be 6 point something, 6.1-ish. So approximately 1/6. It won't be just 16. Right? Okay, the calculation is correct. So example, yeah, I showed you guys the example. Then we'll be doing numericals to add an example. So of course, you guys can simulate things over here, make use of this. Right? Again, add few more things, and you will be able to see those values over here as well, and on the graph. For that, you need to know a bit of coding. That part of the calculation needs, actually even this also needs a bit of calculation. I mean, bit of Python knowledge to add also. If you add and not add over here, it won't work out. Okay, anyways, that is, I'll be teaching that in the coding section. So let's not go to that. Again, what is that we are trying to do? We are trying to find the weight of the object on the surface of the moon in comparison to weight of the object on the surface of the earth. So how is that we're going to go about doing this? Well, we have to make use of universal law of gravity. So when we divide this, what do we end up with? G and G and MO and MO, that is mass of the object, will get cancelled, and we get this particular expression. On substitution, approximately we'll get 1/6. You guys can do with your calculator, you'll get 1/6 itself. Okay guys, and end of it we have, end of it we have the weight of the object on the surface of the moon is 1/6 times the 1/6 time that of the weight of the object on the surface of the earth. That's your conclusion. Okay, so please pause and copy this off. You need to copy this.